Hey guys, Mr. Bowman here. Today's learning objective is in white, and we are learning to identify when to use the sine and cosine rule to solve problems. And what this lesson is going to focus on is when do we use the sine rule and when do we use the cosine rule. And sometimes they're a little difficult to figure out, and we're going to go through those. So we've got two examples on the left, which we're going to start with, and then we're going to move on to the example on the right as well. So the first step, what I like to keep an eye out for, when do I use the sine rule? And that's when I'm dealing with two pairs of angles and sides. And I'll explain what I mean that in a little bit. And when do we use the sine rule? Well, that's when we're dealing with three sides and one angle. And the key thing I want to note, both of those includes things that we are trying to find. So they're trying to include x in the examples that we're looking at. So let's get into the two scenarios we're looking at. So what we can do, we can see the x and the x in both of these. And for the criteria we're looking at, both of those are going to be included. So if you go across here, so if this here was big A, that there would be little a. And that there is what I'm talking about when I mean a pair of angles and sides. So we have a pair there, and if you look across here, we've actually got another pair of an angle with a given side as well. And if you have a look the other direction, we don't have either of those. So that one there, that means we've got two pairs, and that means we're going to be applying the sine rule. Below that, so let's have a look. We're dealing with three sides and one angle. So here we've got three sides plus one angle. And that tells me that I'm going to be wanting to use the cosine rule for that question. So hopefully that makes sense. Two pairs of angles and sides means you're using the cosine rule, and three sides and one angle means you're going to be using the sine rule. So what I'm doing is I'm quickly going to rub out all of that, and then we're going to actually get into solving the questions and finding out those values for x. Okay, so we've already figured out, well, we're using the sine rule up here, we're using the cosine rule down there. So let's start off with the first question. We're going to start off by labeling our sides. So this time around, it doesn't really matter for the sine rule. It doesn't matter what you're angling or what you're labeling. So we've got A here, little a across that. We've got B here, little b across that. And we've got C up the top with a little c across that. So based on this, we're dealing with the A's and the C's. And that'll give us enough information to start our equation. So we're going to have A divided by sine big A. That's going to be equal to C divided by sine big C. From there, we're going to start substituting in what we know to our equation. So we know to little a, that there is 6.7. So that's going to be 6.7 divided by sine big A, which is the unknown variable x, which is what we're trying to determine. We then do the same for C. That's going to be 8.1 divided by sine 97. From there, we do our algebraic rearranging just to solve for x. So here what we're going to do is that 6.7 is going to be equal to 8.1 times sine x, and that's the divide by sine x, move to the other side. That's going to be divided by sine 97. We then move the sine 97 over, that's division, so it'll become multiplication. 6.7 times sine 97, that's going to be equal to 8.1 times sine x. We then take the 8.1 over, so 6.7 sine 97 divided by 8.1, that's going to be equal to sine x. X will be equal to sine -1 of all of that on the other side, so 6.7 times sine 97 divided by 8.1. And when you put that in your graphics calculator, you should get 5.2 degrees, and that there was rounded to 1 decimal point. And that there would be our degrees or our value for angle X. So we've done that. Let's switch pen colors. And let's have a go at the cosine one that we figured out. So just to clarify, we're dealing with 3 sides and 1 internal angle. So that means cosine rule. From this scenario, we want to be labeling the given angle A, which means the opposite one is little a. In theory, we'll be labeling that angle B and then that little b, but we don't actually interested in that big B. And same here, we've got big C for the angle and little c, but we're not interested in that little c. We then write down our formula. So we're dealing with the cosine rule. So just a reminder, that is going to be equal to a squared is going to be equal to b squared plus c squared minus 2bc cos a. From there, we then start substituting. So little a, that's x. So that's going to be x squared plus little b, which is 6.7, 6.7 squared plus 5.2 squared minus 2 lots of 6.7 times 5.2 times cos angle, which is 117. From there, we can go through just to simplify this a little bit. So x squared, well, that's going to be equal to 27.04 plus 44.89, written 7, but that's 89, minus 69.68 of cos 117. That there means x squared is going to be equal to 71.93 minus 69.86 of cos 117. From there, I'm going to move the square over as a square root. So 71.93 minus 69.68 cos 17. And when we put that into our graphics calculator, hopefully you're getting 10.2 centimeters. And I, again, rounded that to 1 decimal place. So hopefully you found the first part of our video useful. Hopefully you figured out, well, or got an idea, when do we want to use the sine rule? When do we want to use the cosine rule? So if you haven't got these examples down, please pause the video, write down when we use each, write down the 2 examples. And I'm now going to clear the working, and we're going to work on our harder final question up the top. Okay, so we're now moving into our big example, one down the end. And what we're trying to do here is we are trying to find out sine x, angle y, and angle z. So what I'm going to do, just to start off with, it looks like I've got less work to do with the sides. So I'm going to have a go at calculate side x first. And from here, we just need to inspect, well, what information do we have for us? So we've got the opposite angle, which is 47. So that means we've got a pair, and we've also got 2 sides. So far it could be either of them. And from that, we've actually also got 2 extra sides. So for me, that's a dead giveaway. We're going to be using the cosine rule to find out side x. What we're going to do from here, we're going to label our triangle. So really important, when you're dealing with the cosine rule, the opposites, the angle of interest must be big A, which means that angle there, or that side must be little a. And then the other 2, B and C, that doesn't really matter which way around they are. So the first part of our question, we're going to be using the cosine rule to find out angle X. So let's substitute everything in. So little a will be x squared. That's going to be equal to little b, which I've said was 10, plus little c squared, which is 11, minus 2 lots of 10 times 11 times cos 47. So x squared is going to be equal to 100 plus 121 minus 220 cos 47. And from there, x squared is going to be equal to 221 minus 220 cos 47. X will be equal to the square root of 221 minus 220 cos 47. And when you put that into your graphics calculator, x should be equal to 8.4 centimeters, and I've rounded that to 1 decimal point. So we've now figured out what side x is. So what I'm actually going to do now is I'm going to clear the letters that I wrote before, because that may impact the next question. So I'm going to write down that x is now 8.4 centimeters. We're now going to figure out the next one. I've just accidentally realized I rubbed out angle y, but we'll put y back. So we may as well carry on alphabetically. So let's try to have a look. Well, what's angle y? So we're trying to find angle y, which means that's of interest. We've got the opposite side. So again, we've got a pair, or we've got a side and an angle. So it could go either way. And we've also got the side and the side. So we could use the cosine rule, because we've got an angle and 3 sides. And actually here, so we've got the pair, we actually could use the sine rule, because we both got both of those c's as well. So if you find one rule easier than the other, you should definitely use that rule in this scenario, because you'll get the same answer either way. But here, just because we haven't used the sine rule yet, I'm going to use the sine rule as well. So let's get into our labeling. So we've got big B here, little b. We've actually got them all labeled already anyway. So we're going to use the labels given by the triangle. So we're using the B and C pairs. So that means little b divided by sine big B, that's going to be equal to C divided by sine big C. So 11 divided by sine y, that's going to be equal to 8.4 divided by sine 47. From there, we carry on. So we're going to go algebraically, 11 is equal to 8.4 times sine y. And that's the opposite of divide sine by y. Sine 47. That means 11 times sine 47 is equal to 8.4 times sine y. 11 times sine 47 divided by 8.4 is equal to sine y. So y is going to be equal to negative or inverse sine 11 times sine 47 divided by 8.4. And when you put that all into your graphics calculator, hopefully you get 73.3 degrees. And again, I've rounded that to 1 decimal point. That means we've now figured out angle y. So that there is 73.3 degrees. So we're lucky here, the last step, finding z. So I'll just do it down the bottom here. Well, we're just going to use the internal angles of a triangle rule. So we know that 47 plus 73.3 plus z, all of those need to combine to get 180. So z is equal to 180 minus 47 minus 73.3. And z came to 59.7 degrees, and that there was affected by our 1dp rounding earlier on. So hopefully you found this video useful. Hopefully you'll be able to say to yourself that you are able to figure out when do I want to use the sine or cosine rule. And just a friendly reminder, if you've got 2 pairs of angles and sides, you can use the sine rule. If you've got 3 sides and 1 angle, you can use the cosine rule. There is occasion, just like the question we just did, where you can use either rule. In that case, use whatever rule you're most confident with. Thanks for watching, guys. Let's get into heaps of practice now.